In the previous video, I talked about radian measures. In this video, I want to talk about converting radians to degrees. Just to review, circles can be measured in radians or degrees. So as you move around a circle, this could be 30 degrees or pi over 6 radians. A circle has a total of 360 degrees if you go all the way around. Halfway around is 180 or pi radians. So if you want to convert, there's a formula. It's pi over 180 or 180 over pi. And you use either one of these, whether you're going from radians to degrees or degrees to radians. So let me give you an example. If you want to convert 140 degrees to radians, you would multiply by pi over 180, so that you'll have pi in your answer. When you multiply this, you get 140 pi over 180. You can reduce this by dividing by 10, which gives you 14 pi over 18. And you can reduce that by cutting these in half, which is 7 pi over 9. So 7 pi over 9 is the same as 140 degrees. So that's the degree measure, that's the radian measure. So that's how you convert from degrees to radians. If you want to convert from radians to degrees, let's say, for example, we have 5 pi over 3. I would multiply that by 180 over pi, this formula here. It's the opposite of this one. And it's easy to remember which one to use because the pi's need to cancel in this case because you're going from radians to degrees, so you got to get rid of the pi. So pi cancels. You could simplify this. 3 goes into 180 60 times, and then 60 times 5 is 300. So it's 300 degrees. So 5 pi over 3 is 300 degrees. And we could have used logic to figure that out because pi over 3 is 60 degrees, and 5 times 60 is 300. But anyway, this is the formula that you use to convert. So use this one when you're going from degrees to radians, and this one when you go from radians to degrees. Okay, there's a few things I want to show you in this video. I also want to show you how to draw angles. So if you were to draw a 150 degree angle, you would start with what we call the initial side, because the angles have two sides. The initial side, and then if we had a moving arm going around, sort of around in a circle, if you were going to draw, let's say, a 150 degree angle, you would end up somewhere over here because we know this is 180. So if you're going from here to here, that's 150 degrees. We call this side the terminal side. That's where the angle ends. To terminate is to end, to finish. So you start here and you end here. So think of this as a moving arm that's sort of opening and closing. So we open up to 150 degrees. So that's how you draw an angle on an axis. You could do that, of course, in radian measure as well. So if you were drawing, let's say, 5 pi over 4, we talked about pi over 4 being the same thing as 45 degrees. So we have our initial side. 45 would be here. We need 5 45s, or 5 pi over 4. So we'd say 1, 2, 3, 4, 5. This would be 5 pi over 4. Okay, so that's what that looks like as an angle measure. Notice that I keep going counterclockwise. That's not always the case. You can draw a negative angle measure. So if I asked you to draw negative 30 degrees, you would still start with your initial side here, and you would go down 30 degrees, which would be about here. And you just show your arrow indicating that you went negative 30, as opposed to going this way, we went this way. Okay, so you can have negative degree measures. And that brings me to the last thing, which is called coterminal angles. So let me write that. Coterminal angles are angles that look the same. In other words, if I was to draw, let's say, a 30 degree angle again, so I'll do it like this, 30 degrees, and so it looks like this from here to here. If you were asked to draw a 390 degree angle, you would start here. You would go all the way around the circle 360 degrees and then 30 more, and you'd end up in the same place. So it's called coterminal because they're two angles that look exactly the same. If you asked me to draw a 390 degree angle and a 30 degree angle, they would look the same. The only difference is you went around the circle an extra rotation. So it's basically 300 plus 360 is 390. So that's how you find a coterminal angle, is you just add 360 to whatever angle you have, and you'll get another angle that ends in the same place, and that's called coterminal. And of course, if you can go forward, you can go backwards. So if you had a 30 degree angle and you subtracted 360, you'd get negative 330, and that's coterminal. That means that ends in the same place. So really, there are infinitely many coterminal angles because you can have a 30 degree angle, you can go 360 degrees around and get 390 and end in the same place. You could add another 360, which gives you 750, and you'd go all the way around and end in the same place again. And you can just keep going around and around and around. So there are infinitely many coterminal angles with any given angle. Okay? So you'll be asked to find coterminal angles. It's very simple. If you're given 40 degrees and I said find a coterminal angle, you would just add 360, which would give you 400 degrees, and you say, okay, that's coterminal. If I asked you for a negative coterminal angle, you just take 40 and subtract 360, and you'd get negative 320, and that's also coterminal. Okay, and that's basically it for coterminal angles, other than the fact that, of course, if you can do it in degrees, you can do it in radians. So if you had, let's say, pi over 6, pi over 6 looks like is 30 degrees, so looks like this, pi over 6. You wouldn't add 360 to that to get a coterminal angle. You would add 2 pi, because 2 pi is a complete rotation when you're in radian measure. And in order to add 2 pi, you'd have to have a common denominator here, so you need a 6 here to add to this fraction. So if you multiply this by 6, you have to multiply this by 6, so you get 12 sixths. And that should be obvious because 12 sixths, 12 divided by 6 is 2. So this is the same thing as 2 pi. You're just calling it 12 pi over 6. And when you add 12 pi over 6 to 1 pi over 6, you get 13 pi over 6. And this is coterminal with this. So if you asked me to draw through 13 pi over 6, I would start here, go all the way around, and end here. And it's coterminal with pi over 6. And of course, if you can add 12 pi over 6, then you can subtract 12 pi over 6. And you would get negative 11 pi over 6. And that's coterminal. So all three of these are identical when you draw them. They are coterminal. And that's it.